Hey guys, so for math, we are moving on to topic 10, which is actually volume. But I want to do a little review because I want you to remember a couple of things that we've learned before that's going to actually help us with volume. You learned in 4th grade that perimeter has to do with a two-dimensional figure in which we measure the length and the width of something, a polygon, and we take that length and width of each side and we add it up to get the full perimeter. Now this is pretending like we had a garden and we had to put a fence around it. So since that's a total length and width around the garden, it's 5 yards plus 3 yards plus 5 yards plus 3 yards. So then the fencing that we're going to totally need is 16 yards. Easy. Then we moved it up a notch. We wanted to know how much space we have in that garden so that we could plant our roses. So then we would do measurements again of the length and the width. But as we learned, to get the square area, we need to multiply area equals length times width. The length is 5 times 3 which is the width. So we get the answer of 15 square yards. See where I said square and there's a little tiny 2 there? That 2 stands for the 2 dimensions of length and width. Now, with that being said, we're going to move on to volume. Volume is when you take, it's not 2 dimensions anymore, it's 3 dimensions. This box is not 2-dimensional because it has length, it has width, it has length, it has width, but it also has height. And we do that when we're talking about solid figures. So this happens to be a rectangular prism. I went around the house just to find different rectangular prisms. This little box, it says that it has clay figures in it. So, oh no, it's got like rocks and jewels and stuff in it. So solid figures, if I want to know how much I can put in this solid figure, I need to know the volume. Here, perfect example of another rectangular prism, our friend SpongeBob and Patrick on this beautiful lunchbox. And if you open it up, actually there's no lunch in it, it's Lego figures. So we would have to find out how much space is inside this lunchbox. We would need to know the length, the width, and the height. And here's a very simple rectangular prism, which is kind of cool because it's clear. Now, and I want to know how much space I can actually put in it. Well, the way that we would do that is we would fill it up with cubic units. It's almost like, how much cubes can I fit inside of this? Oh, look at that. I have a cube right here. So could you guesstimate how many cubes, Rubik's cubes, could actually fit inside this salad box? That's something to ponder. But I want you to think about that because that's actually what volume is. It's taking a cubic unit, and this cubic unit looks like it's about, I don't know, a couple of inches. But cubic units can be in feet, and you would use cubic units in feet for if you were measuring the amount of water in a pool. But builders needed to find out how much space is going to be inside their building, because that's obviously a 3-dimensional figure. And you actually have many things in your house, which is probably something I want to assign to you. Walk around your house. What kind of 3-dimensional things do you have in which you would have to find volume? Okay, so volume. The definition of volume is the amount of cubic units needed to fill a solid figure. So here you have to pretend, this is my drawing here, my 3D figure, and how many cubic units can actually fit inside this solid figure. Now, I made the number 3 really big because I want you to remember the number 3 when we're talking about cubic units or finding the dimensions to find the volume of something, because a solid figure can be measured by length, by width, and by height. And we're going to practice that actually using cubes. So come down to the floor with me, and I set up a couple of models here for you. All right, so in my first model, you can see
that I used like these. I think they're for ice cubes. Like instead of using water, you can actually freeze these and put them in your drink and it makes it cold. So this is a great example of a cubic unit to see that I actually made one. This one is, I don't know if you could see from the video that it's 2 layers high, but it definitely has a length, a width, and a height. So let's see if we can figure that out. So length usually is, if you go straight across, you count the cubes. So I always, and this is how I want you to find volume. So finding volume equals length times width times height. So the length of my first figure is 1, 2 cubes across. My width, which is going back, is 1, 2 back. And my height is 1, 2. I always like to call it floors because you pretend like it's a little tiny building. It's 2 floors high. So my question for you is, what is the volume? So we would take 2 times 2 times 2. You can even use your friends, the parentheses, to help you if you wanted. 2 times 2 is?
4.
Thank you. And 4 times 2 is?
8.
8. So this solid figure is 8 cubic units. Now, there is another way that I can find that out. I could actually pull this apart and count to see if there's 8 cubic units. Let's see if it works. 1, 2, 3, 4, 5, 6, 7, 8. So it worked. That's how you're going to practice and understand the concept of volume, because volume takes up space. Now with this little guy, I actually only did 1 floor. It's a 1-floor building, but its length is very long. Remember, the length is this part here going across. So let's count how many we have. 1, 2, 3, 4, 5, 6. And I want to remember that, so I'm going to always label it L6. Now, width, going back, I only have 1, 2. That's easy. But what is the height? Well, there is 1 cubic unit as the height, so believe it or not, think of it as in terms of a building, it only has 1 floor. So we would say that the height is 1. Do we still use the formula?
Yes.
Yes. So the formula is volume equals length times width times height. So 6, times 2 times 1 is
12.
12.
Yes.
But it's not just 12, it's 12 cubic units. Okay? The next one, a little trickier, but we're not going to get fooled. I just used more blocks. So what I'm going to do is I'm going to show you the length of this. I can't write on this. Is 1, 2, 3, 4. And look how I'm constantly writing L equals 4. That's the habit I want you to get into. You guys are famous for skipping those steps. Yeah. And the width is how many going back, which I count as 1, 2. And the height is 1, 2, 3. So think about it in terms of what is the formula. The formula is volume, length times width times height. And I made a new board just to make it clearer so that you guys understand that the volume, the length times the width times the height. My length is 4. My width is 2. My height is 3. In terms of knowing your facts, I know that all of you know 4 times 2. So you can even put a parentheses around it. I like doing that so that I can see my facts. And then write the product for 4 times 2, which is 8. But don't forget, that's not the complete answer. You still have to multiply the height, which is 3 cubic units, giving us a total volume. 8 times 3, everybody, is?
24.
Correct. So the answer to the volume of this solid figure is 24 cubic units. Now, it could be something as simple as this one
I want you to take a good look at it. Can you focus in on that, camera person? Because I want you to be able to try and do it yourself. And the way I want you to do it is I want you to take a really good look at it. I'm actually even going to pull it apart to see if you can identify its length, its width, and its height. So here we go. So I'm going to build it all over again. I've got 2 in the front, 2 in the back, 2 on top, 2 on top. That's my second floor. So I want you to think to yourself, what is the length, what is the width, and what is the height? So that's an easy one. I'm going to ask you that. All right. End video. Okay, so when you go into your book tonight to work on lesson 10.1, I just want you to be familiar with some of the questions that you're going to be asked during your practice. So obviously you're going to be asked to find the volume of the each solid figure, and the unit cubes help you. I don't want you to sit there and try to count each one. I really want you to just count what you see and then use the length, the width, and the height to find the volume. So for example, I looked at this solid figure. I figured out that the length was 4, 1, 2, 3, 4. The width was 2, 1, 2. And the height was 1, 2, 3, 4. So how would we find the volume for this solid figure? I already have it nice and labeled for myself, so I know that the next step I have to do is just do the formula. 4 times 2 times 4. Think about your facts. You can use parentheses. 4 times 2 is
8.
8. Don't forget the 4, the height of the solid figure, and 8 times 4 is
32.
which is why it is so important to know your multiplication. Oh, cubic units.
That's okay.
Yikes.
Nobody's perfect.
All right, so
Nobody's perfect.
this is something I want you to think about because this is like a question in your book. They present to you a solid figure in which you're going to have to find out the length, you're going to have to find out the width, you're going to have to find out the height. However, they're going to ask you what would change if we added another layer. Well, which dimension would change if we added another layer? Would the length change?
No, ma'am.
Would the width change?
No.
Would the height change?
Yes.
So, if the height changes when we add a second
It's
layer,
like a cake.
yes! Even better. That's better than buildings.
We love cake.
We definitely love cake with lots and lots of layers. So I want you to think about that. So the length of this solid figure is 1, 2, 3, 4, 5, 6, 7 cubic units. The width is very easy. Why is it so easy?
Because there's only one.
1 cube. So 1 cube going back would be my width. And the height is really easy too because it's only 1 cubic unit.
But aren't we adding the layer?
Yes, we are going to add the imaginary layer right here. See, it's imaginary.
It looks like
It's
a
not
potato.
real yet. Yeah, it does look like a hot dog or something. So now we actually changed the volume because originally, the original volume would have been volume equals 7 times 1 times 1, which is what?
7.
7 cubic units. But the volume, would the volume change if we added another layer?
Yes.
Yes. How would it change?
It will go to 2.
Yes, the height would be 2. And so now it's 7 times 1 times 2, which is
14.
14. So if a dimension changes,
The whole volume changes, baby.
exactly. So good luck tonight on your homework. I will be assigning you your practice pages. I haven't decided which ones yet, but remember, you're going to work on it, and we will be checking the homework the next day for our 9 a.m. math meet. And that's volume.